yeah, or current carrying wire. So meaning a wire with the current is going through. We can see that wire with current. Yeah. So that wire with current is within the magnetic field. Then there will be magnetic force acting on the wire. Yeah. And in order to define the direction of the magnetic force, we need to know, yeah, the direction of the current and the direction of the magnetic field line. Yeah. And in order to define, then we apply the left-hand rule. What you answer is too short, because we are trying to elaborate a certain situation. Those things students already study at grade 9, but for the grade 7, students will study more in terms of quantity. Yeah. So for certain concepts of physics, then we need to teach students the quality or the qualitative aspect, what it is, or the quantitative aspect, how to define it. So for grade 11, we teach students how to define the magnitude of the magnetic force. Yeah. So, okay, so thank you, Ngọc. So this is just a warm-up. So there will be more exercise for you this morning. So please stay focused. So I like to ask someone else. So Trịnh Đức Nam, you look serious. So we continue with the situation, yeah, there. So how to define the magnitudes of the magnetic force in this case?
To define the magnitudes of the magnetic force that exert on the current and the wire carrying a current, so we use the formulas. The F equal to B multiplied with I with L psi and theta, where B is the magnitude of the electric field, I is the current on the wire, and L is the length of the wire, and theta is the angular between the direction of the current and the magnetic fields.
Yeah, that is it is by the end of the lesson, students should state, let's say, yeah, should recall the formula to define the magnitude of the magnetic force. But what we try to teach in physics is not just the formulas. Yeah, we teach students the way of thinking, the way of defining the things we do not know. So let's continue with the situation, because that is not just a situation between you and me. That is the situation of the lesson I try to engage you in. Yeah. Wow. Because the magnetic field causes the force. Yeah. So meaning that in order to define the magnitude of the magnetic force, we need to know the magnetic field strength. In this case, we call B. Yeah. It's just a symbol. Yeah. Magnetic field strength. And if the wire has no current, then there's no force actually. Even it is in the very strong magnetic field or strong magnetism, yeah, then it seems that the magnetic field and magnetic force also depends on the current, yeah. So the more the current, the more the magnetic force. Do you agree now? Do you agree with my prediction?
Yes.
Yeah. So it means that in order to define the magnetic force, we also need to know the current. the magnitude of the current. Yeah, and of course the length. Yeah, because you know that we can divide a certain wire to a smaller part. Yeah, and each part will be under a certain force. Yeah, the same current, the same magnetic field strength, the same angle, so meaning the same force. But if we have more wire in series, so there will be more parallel force. So those parallel force can be also add up to a resultant force, which is of course a lot bigger than the component force. So meaning the longer the wire, so the bigger the magnetic force. Do you understand what I predict, not mine? Let me explain again. Now, we consider this length of wire. Yeah, there's a current going through. It is, or let's say it's a wire. It's easy for you to imagine. So this is a path of the wire. Yeah, so it is in the magnetic field. There's a current going through. It is in the same magnetic field, or that, how to say, the magnetic field is the same for every point in the space, in the nearby space. Yeah? Or okay, so it's called uniform magnetic field.
Yes, uniform, yes.
Don't worry. So in case when we could not load a certain word, we try to explain it, and the right term will come. Okay, the uniform magnetic field. Yeah. Then we will see. I'm trying to predict that the longer the wire, so the bigger the force. Let me try. Now we can divide this force into two parts. Yeah. So for this part, my finger, it's still the same current, the same magnetic field strength B, the same angle, and for this part also the same. So meaning that there's a force acting on this part, maybe it's going upward, and there's another force acting on this part, also upward. So meaning for the whole wire, there will be a bigger force, which is the resultant force of the two component force, left and right. Yeah? Yeah. So meaning that if we have a longer wire, so we have more path, yeah, and meaning more force acting on each path. So meaning the resultant force acting on a longer wire will be bigger than the force acting on a shorter wire. Now you understand?
Yeah.
Normally, do you understand?
Yeah.
It is just the deduction. It is just the prediction. It can be true or not. So anyway, so meaning that in order to answer, or in order to find the answer for the question how to define the magnetic field, magnetic force, we need to define the current, the magnetic field strength, the length of the wires, and also thinking of the case. Maybe I ask another one. I already asked. No. Now I ask Link. Are you Ling or Huang? Suppose you are Huang Ling. Your given name is Ling. Ling. Are you ready? Are you ready to answer my questions?
Yes.
Okay, let's go. Let's think of the situation that there's a current in a magnetic field, and students already know in grade 9 that we can define the magnetic force acting on that wire by using the left-hand rule. Yeah. Link, can you please show me a certain cases in which even there is a current, even there is a magnetic field, but there is no magnetic force? Just 10 minutes ago, I said that one of the characteristics of the magnetic field is that if we put a certain current or a certain permanent magnet in it, then there will be a force acting on that. Yeah? It is like the magnetic needles, yeah, or compass, let's say, or compass on magnetic needles, which is small and which can turn around a certain point. Then when we lift that needle in the magnetic field, then the direction of the needle will change. So this kind of indicator for the existence of the magnetic field. Yeah. But I asked Ling for a certain case that even there is a current, even there is a magnetic field, but there's no force acting on that. So it seems contradict to what I have just talked. But there's one situation like that. Do you know? Ling and Nam have the same bookcase, so it seems that you are in the same room. So please ask him.
Left hand sure.
Now, Ling, you are going to be a teacher very soon. If you could not answer, just say things. Don't just be silent. Teachers, I'm not so sure. So please let me think a little bit. Could you please ask another classmate? Then for me to think, then I will raise my hand when I have answers. Let's say it like that. No problem. Don't just be silent. Yeah. When you are in front of any problem, yeah, any questions, so just react to it to a certain extent, to postpone it, or to try to avoid it, or try to go through it. It is your choice. But try to react something. Ling.
Yes.
How you react to me?
Yes.
Not that yes. Or I think you do not understand what I say. Em không hiểu thì nói gì không?
Dạ em không hiểu hết được.
Thật là đau khổ. So maybe I ask Đức mình, can you give me the example where there's the current in the magnetic field but there's no force? Mình
Gọi em à? The case which we have no force is we place the wire is parallel to the magnetic field, so that the
the angle in this time is equal to 0, so the sine alpha is equal to 0.
Okay, so the focus here. Yeah, makes sense. Yeah. So in such case, we could not apply the left-hand rule anymore. Yeah. So it's meaning that this doesn't exist in magnetic force. Thank you, Dudley. Yeah, you're not so good, Dudley. You know the answer, so you should help Ling a bit when she's a little bit anxiety. Yeah. So you should help her. Okay, so that is it. So we can start the lesson with the situation as I try to simulate, yeah, and then student will have in mind that the magnetic field strength, yeah, may depends on the strength of the magnetic field. The magnitude of the magnetic force, may depends on the strength of the magnetic field, the strength of the current, the length, and maybe the angle. Because there's a certain angle, there's no force, and the other angles there's a certain force, I think. So this means that. But in order to define such magnitude, we need to. It's not just like the magnetic force depends on the certain factors, but it's more important how it depends on. Yeah, so meaning that we need to see case by case how force depends on the current. Yeah, how force depends on the magnetic field strength, how force depends on the length, and how force depends on the angles. Yeah, those are the things we will investigate in this lesson. Yeah, and there's at the moment there's no theory to support our answers. Yeah, we cannot perform the theoretical deduction from what we already know to the answer. Yeah, so meaning that we need to carry out the experiment, yeah, in which we change the current and then we measure the force, yeah, in which we change the length and then we measure the force, in which we change the angle and then we measure the force. Not my good thing it can be the approach to the problem. No? Yes?
Yes.
What do you mean by yes? What do you mean by yes? What teachers and students will do together to solve the problems?
I think the solution is correct.
Yeah, but what is my solution? When from my row, I couldn't see the other member of the class. There's still 9 others I could not see.
I try to change. So how about you can see the more? There are 3 dots, and you see it and change your analyzer display.
Yeah, but how to switch the displays?
You could see the 3 dot in the
okay.
That's the vertical. And choosing.
I can see the whole screen. Yeah, nice. Okay, okay, I will not lose time with you. So meaning that we need to do the experiment because there's no solution for solution for theoretical deduction. So in order to ensure the fair experiment, we want to investigate how the magnetic force depends on the current. Yeah. So meaning that we need to keep the other factors unchanged. Yeah. So meaning that we use the same wires, so there's no change in length. We put the wire in the uniform magnetic field. Yeah. So there's no change in the magnetic field. We do not change the angle. We keep it as it is, stand still. We simply change the current going through that. Yeah. So meaning we need to supply the current to the wire. Maybe we connect it to the power supply, the batteries. We need a switch. Yeah. We check this variable resistor or rheostat in order to change the resistance of the whole circuit, meaning we can change the current. Yeah. And we also need the ammeter to measure the current. In order to measure the force, there are at least two solutions. And there is also a question for you to compare between the two solutions with the two experiments to measure the magnetic force. The magnetic force in this case is so small. Yeah? So there should be a smart solution to measure the force. So that is something I leave it for that to guide you through. Yeah. And I already interact with the first line, and the second line I have no Chinese, like Chi or Hill. You have nice hair here, but a little bit long. Go to the barber shop to cut it a little bit. Or maybe you will put it a little bit, like that. Oh, it's handsome. A little bit of playboy. Okay, and Kate, last time he was active, and today hopefully Kate also active. And Lê Anh and Nhật Hà, etc. Tú Khuyên, Thu Thủy, and still two others. I already asked Khuyên to help me from now on because I have a meeting. But I sometimes I will visit you. But anyway, Khuyên will coordinate the discussion this morning. So Khuyên, please go through first of all, what students already prepared in terms of kind of pre-session activities, yeah, and then discuss with them some key points about the purpose of the experiment. I already do part of that, yeah, and then in order to answer the question of the lesson, then a student need to do the experiment. And that should be the major part of this morning. And are you heard that?
Yes, I'm here.
Okay. Please also you turn on the camera. So that will coordinate the part with the analyzing the videos. Unfortunately, we do not have a chance to do the experiment, but we try to make it effective by analyzing the video, and that will guide you through the video. And I suppose you already watch it in advance, and that no matter what you do, but by the end, students need to answer all the questions about the experiment skills. Yeah, that try to ensure that.
Yes.
Okay, so Quinn, please. Thank you.
Yes. Okay, so in this morning, and I open the THVLPT and find out in our class just only four students. What is it? Oh, okay. Yes. So I only see 4 students submit for the part 1, the preparation. Nhật Hà, Hoàng Linh, Tú Khuyên, and Hà Ngọc. So I download it, and for the next week, please finish one before you go to the class. The second point is, do you remember we have the e-portfolio, and you need to do it before the next.
Có trên dưới 10 em thì
I need to mute Professor Jane first. Okay, muted. Yes, for the CST, and only for students, and I will continue. And remember, you need to create the portfolio, e-portfolio. As Professor Jin mentioned in our last class, and this one is not only for this course. This one is to be used for the other course related to the teaching methodologies. For example, the planning lesson, or also the implement the lesson. So you must create the e-portfolio. So remember, you still have the work to create the e-portfolio. Regarding to your preparation, I will share. So I just random and I just random and also open one. Yes. And also for the preparation, the first question is comparing to experiment, and some of you already answer it. So after that, you can discuss together and also think about we have two experiment and what is the advantage or also disadvantage related to this one. And the second question is quite important. Maybe at the end of our class, after you do the experiment, and I will ask you again. The question is in your option 1, the experiment 2, and we do not read the dynamometer reading when the needle is deviated, but we have to pull the dynamometer down. Yes, so why we need to do that? And the third one is the magnetic induction. So in here you can using the term for the magnetic flux density, cảm ứng từ, in the permanent magnet in the option 2 of the experiment 2, proportional to the number of the magnet and y. So now the time for you to do for the part 2. For the part 1, the preparation, you can still have the time to reread about the question and also try to answer it. Okay, so if you didn't see the video and it's quite hard for you to answer some question like this, I could give you more opinion and also comment if you do it, but just only 4 people and maybe don't have much more idea or comment on this. So right now you will have 1 hour to do all the tasks on the CST. Yes, this one is the CST. For the week 2, and you will have the experiment report. So you need to address all the question. Do you remember we have the sign, the Google sign, and click in this one to find the sign and also the video, and answer the part 2 and think about when you do the part 2, please think about the part. Please think about for the part 3 how to teach with the physics experiment. It means like how you can put such experiment in your teaching process. Any question? Do you have the link for our Google site? Do you have this link? You already have, right? This one, and click to the tab week 2. So you could see several video, and maybe at the end I will ask you why do we need to do several experiments. In the first part, and teacher Trin, he already explained to you, but maybe at the end, and I will ask you again. This one, why do we need to do several experiments like this? And also think about your teaching idea in this one. Now you will have 1 hour to do the part 2. It's the time for you. No question, right? Yes, okay. Okay, so right now you can yes, you could turn off the microphone and also the camera, and then you go to the Google site to find your task related to the experiment report. Yes, Dad, go ahead.
I want to notice you that the deadline of the task is today's noon. So it means that you have to finish all the tasks in the part 2 before the end of the lesson. So so you have to submit all the tasks in the part 2 before the end of the lesson. Cái này thầy Trình có nói rồi, nhưng mà mình nhắc lại bằng tiếng Việt, tại vì cái này quan trọng này, đấy là ở mỗi buổi học thì cái phần 2 ấy, các bạn phải nộp trước khi buổi học kết thúc. Tức là khoảng 12 giờ, deadline là khoảng 12 giờ, nên là cái nhiệm vụ này các bạn phải hoàn thành luôn trong tiết học nhé, chứ không phải để về nhà đâu. Nên là các bạn phải rất là active trong cái tiết học thì các bạn mới xong được cái nhiệm vụ, ít nhất là xong được cái nhiệm vụ thứ 2. Còn nhiệm vụ thứ 3 thì sau đấy cô Quyên sẽ hướng dẫn các bạn nghĩ và các bạn sẽ hoàn thành trước cuối ngày. Đấy, thì deadline của các nhiệm vụ là như vậy.
Based on my experiences and in my last class, your friend, they are quite hard to complete all of the tasks in 1 hour. So please try to finish all of the tasks in the part 2 in 1 hour. Then you could submit it at by noon today. Yes. So go to work. Any question? No, right? Okay.